Hello viewer, this video will be a hands-on tutorial on a specific security tool, Scyther. Actually, Scyther is basically a formal method-based security verification tool, and it was devised by a cache schemer while doing his PhD work. So actually this tool helps us to do formal analysis and verification of abstract security protocol. Though there are other contemporary tools, for example, ProVerif, Tamarin, and Avispa, this tool is very easy and reliable for testing the security features. It actually evaluates security properties and checks if the tested protocol are robust enough to withstand known attacks. So I have chosen a virtual platform, that is your Oracle VM VirtualBox Manager, and this tool will be installed on a virtual operating system, that is Ubuntu. It's a Linux based distribution operating system. It's a Linux based operating system. I will simply start on the basic tool installation and write protocol on this and test its security feature. So at the initial stage, let me start this operating system. So viewer, when you have this is the interface of Ubuntu 6.04 operating system, and at the initial stage, we need to download the tool from internet, and for that we need to go to the internet. So let me open the internet. So we can go to this website, that is https people.cispa.io Cascramer Scyther, and here you can see we have three different versions of this tool, and it is available for Linux and Windows and Mac OS operating system platforms. So we are interested on Linux version, so we'll click it and download. So we'll simply save the file. Okay, so let me go to the download. Yes, it was of 1 MB, so it has already been downloaded and it is there in our download folder. So this is the folder that we have. So simply I will take this folder and copy it, right click, copy it, and I'll put it in my home folder, and there I will extract it. So it is already extracted, so let me close it. Okay. So this is in the name of Scyther Linux -v1.1.3. So let us go inside this tool and see what is there in our Scyther security tool. It is with a Python. This tool is written in Python program, so you can see the application file in scyther.py. There is a graphics user interface version, scyther-gui.py, and we need to run this file and just run the tool and we'll get started. It is also come with different test protocol. There are so many tested protocol. These are security protocols. So we'll test them. We'll write protocols from the scratch and we'll understand how it tests the security protocol. So let us go to the terminal. For this, we'll need the terminal to run the. So initially we'll see where we are, pwd print working directory. So we are in the home and AMI directory. So let us see if we have our Scyther folder here. Yes, Scyther Linux version 1.1.3. So I'll go to this folder, cd sc Scyther, and here I need to run the file. But before that I need to check. Let me check. And yes, we have to run is Scyther-gui.py. But before that, we need to install the basic dependency of this protocol. So what are the basic dependencies? Let's go to the website and see what are the things we need to install. So for that, we need to go to the installation tab of the website. There's the installation tab, and there we'll copy this line. This is super user do apt get install. What we need to install? GraphViz is a graphics visualization. Along with, we need to install Python with a dependency of library Python -wxgtk 3.0. So simply I will copy this, take it here and paste it here. So I will install this. So let me put it enter. I'll input my password, super user password. So it will start installing. Okay, I'm sorry, it is wrong. So let me try again. Yes. So actually I have already installed all those things, so it is not taking much time, and it is saying yes, whatever requirement is there, it has already been installed. Like GraphViz is already installed and it is in newest version. Python is also installed in its version, that is 2.7.12. There is a note, we are using 2.7 version, we are not using the 3.0 version. Okay, so after doing this, we are ready to go for running our Scyther tool. For that, what we need to, we'll simply run the Scyther Python file. So I will write current folder dot for the current folder dot slash. As we see, we are in let me see where we are, pwd. We are in Scyther folder, and we have already seen ls, yes, and we have Scyther-gui file is here. If you can see it, this is the file we need to run. So current folder dot slash Scyther-gui.py. So yes, if you press enter, there you go. Yeah, so we have this tool. This is the tool that we are talking about, and it has very simple one clean slate for typing the protocol, and another tab is there for setting. So we'll see all those in later classes. We'll see all those settings. So initially, let me choose a file and open some existing protocol and see if it is working fine or not. So go to the protocol. These are the existing protocol that we have. So let us first take a small Yahalom Ben SPDL file. Okay, this tool takes the file written on SPDL language. Okay, so yeah, this is how it looks like. At the beginning, let us see, this is the comment. Any string begins with a hash symbol will be treated as a comment by the tool. Then we have some variable, and this is the session key is a variable of user type. For phrase is a variable as a constant variable, and it is a function type. Again is a constant type compromise variable, and it again is a function. Okay, so this protocol named is protocol by the keyword. By the protocol keyword, we mean that this is the protocol, and this is the name Yahalom-ban, and it takes three different roles, I, R, and S, and subsequently this protocol will be different parties in this protocol, like I, R, and S will be defined, and their role will be defined. So if you see this, it has role I, role R, and role S. So without going further detail, let us test it. How do you test it? We'll go to the verify tab and verify the protocol. So see, some of its attributes are okay and some of it's failed. So when you fail any property, that means this protocol is not robust enough. So it is vulnerable to two attacks, one with this and another with this. So if I click this attack, this tool will give us okay, this will tool will give us the trace file of this attack. So this will also give us how this attacker can attack the protocol. Okay, okay, this is yes. So this is the way the attacker attacks. This is colored with red, so orange color. So by this means you understand this is the intruder or the 2D attacker, you can say, and this will be the yes. Okay. For now, we understood that we can open a file, and from here we open it. When we run it, open the file, and then we verified it. And another thing we can do is we can characterize the role. We check whether the roles are reachable by the rule or not. And yes, they are reachable, and there are more than one trace pattern. If you click on trace pattern, also you'll find the trace pattern. That means the rules are at least reachable. Means you don't have statements or send and receives are not synchronized. You don't find any uh, send and receive uh, functionality which are not synchronized. So again, we'll see all these uh, basic properties while writing the basic protocol. So let us write a protocol from the scratch and understand how it works. Sorry, I have deleted this. Let me run it again. So /Scyther -uy.py. This is how we run the protocol. So let us write a very basic protocol. So by mean the protocol keyword, I'm writing a protocol, and this is my test protocol with two roles. One is sender, another one is receiver. And this protocol will be encapsulated by a opening curly braces and closing curly braces. And I'll start writing the rule. So by the keyword rule, I will specify sender rule first. I use an indentation, though it is not intent oriented. So whatever indentation you may give, it is fit one choice. So for the simplicity, I'm giving this kind of indentation. So so then I can identify which is rule S and which is role R. So here so role S start the communication. It will send something. So by keyword send is a predefined function send. I will give a number for this to identify what level it is. Let's say send 1. So send 1 will give send the data, and who will send? S will send. To whom it will send? It will send to R. So S will send to R. So first is sender, then second parameter is the receiver. And what it will send? It will send data. Let's say it will send a data, but data is not been defined. So let us define the data. So it is a variable type. I write a variable where data and let it be a fresh variable, and I will put semicolon for denoting the end of the statement, and I will send this. So at the receiver end I need to receive it. So for this I have the function recv, receive, and according to this level 1 I will receive. If send 1 has sent the data, then receive 1 will receive the data. I'm sorry, this send function hasn't ended, so I'll put semicolon to signify the end of the statement. And receive 1 will receive. Who will receive? Again, S will send and R will receive. Okay. Then you may have variable for receiving the data. So let's say receiving data, R data is the receiving data. R data. This is what I did. So what we did here, you see the variable sent by the sender is fresh. Fresh means it is just now created. The data is a variable name and fresh is the keyword, and this of data type. Data is a user type. Okay, and so I mean similarly the receiver will also create the data type R data, and this will be a variable, just a small variable or maybe old variable, and through this old variable it will receive the message. So this send message having sender address, receiver address and data will be copied to this S, R and R data. So the this is a very simple protocol where the role S will create a user data and send it to the role R. Role R will create a user data and receive it. So let us see if it comes with the protocol verification. Yes, this is not giving anything, so this is error free. This specification is good. Nevertheless, we haven't tested it. We haven't tested any such sort of properties of the security. So let us test security properties. So what I do, I'll test the secrecy of this data. I haven't encrypted anything. I haven't done any security feature. Still, let us see if it finds the flaw or not. So to test security, I've used a claim keyword. Claim, and I may give a label. Let's say claim S1, and I write the role name. Role name is S. S will claim what property it will claim. It will claim the secrecy. So this is SECRE, secret, and check the secrecy of which date variable, data variable, and see if it is secret or not. Similarly, this I'll copy this, and I will also want it to be checked for role R. So I'll paste it here, and here as a claim is given by um, the role R. What is not working? And role R will check. So role R will check the secret of R data. So it will receive in R data. So it will check the secrecy of R data. Okay, now let us test. Now let's verify the protocol if the specification satisfy the claim or not. But it failed. See, it had failed the secrecy property of the data. So if you click that, you'll find that anyone can create the data variable and send it to the receiver. And receiver doesn't know which data is from the sender. The receiver, if it is Alice the receiver, Alice has no means to identify whether it has come from Bob or sender. So for that, what we do, we use some security mechanism to safeguard the secrecy of this data. So what can we do for this? We can encrypt the data. So we'll encrypt the data, but encryption doesn't provide the no. Does it provide secrecy? Yes. So we do encryption. So how do you do encryption? I will use a curly brace to designate the encryption. So data is encapsulated with the curly braces, and I will use a key. So there's two kinds of encryption. As per the basic cryptographic tool is concerned, we have one is public key, one is private key cryptography. So for now, we use a symmetric cryptography, that is private key cryptography. So I have a key, common key, and it is shared between S and R. So this is how I write for symmetric key encryption. Whatever data I would like to encrypt, that will be encapsulated with the help of curly braces, and I'll write the symmetric key, this K, and K is shared between role S and role R. Similarly, this received data, R data, at the receiver and R role, I will simply receive this S. I mean, receive with the K key, symmetric key between the shared between S and R. So the way I encrypted here at the sender end, similarly I will decrypt it at the receiver end. I'll use the same key, share key K, shared between S and R. So this is, I sent a encrypted data K and encrypted data with the symmetric key K shared between S and R. At the receiver end, I will also decrypt the same data using the same symmetric key shared between S and R. So let us see if this security provision provides us secrecy. Yes, now it is okay. The status is okay. That means by simply doing a encryption using asymmetric cryptography, we can provide secrecy to our data. But is it all? Are we safe just by encrypting the data? Let us see if we test for another claim, it's claim S2 given a claim by S, and this will claim for non-injective agreement between sender and receiver. And let us have another claim S3, again provided by S, non-injective synchronization. Sorry, this is not a hyphen, this is and I agree, a non-injective agreement. This is NISY and CH, non-injective synchronization property. These two are a very integrated property of authentication. We'll talk about that, but before that, let us check whether this property is satisfied by our symmetry cryptography. So let us see. I'll simply copy paste it because I use same code. So I'm a lazy person, I don't write it, rather I will reuse the code with small modification, that is role S will become role R. Yes, so this is level is okay. Now let us see if this security provision provides us a basic authentication property or not. So let us verify the protocol. Wow, this is okay, this is not having any problem. So by simply doing asymmetric key encryption, we are achieving non-injective agreement, non-injective synchronization. But is that all? Are we still safe? Let us check for another claim. Interesting security property, that is your aliveness property. So S alive. So S will test the property of S alive. Similarly, we'll test it for role R. Now see if both the parties are alive while they are communicating, and see the properties. Here it failed. So aliveness property doesn't satisfy with this set of construction. So what is the attack? Okay. So it is time to to understand these attacks and all and other security properties, we need to look at the theoretical background of authentication properties. So what are the properties it takes? It takes. So before that, we'll go to we'll understand what these properties signify and how by satisfying this property will withstand various practical known attacks.